Good afternoon, my name is Delvis Garcia, and I'm here with Brandon Valdez. Say hi, Brandon.
Hi.
Alright, and today we're gonna be giving you a crash course to the muscular system. So, very fun, I know. Just sit back and relax and enjoy. Alright, so to begin, we first need to understand that the bicep and chest is not the only muscles we have, right? Organs are made from muscles, like the heart. So it's important to understand this, that there is more than just one type of muscle, right? So there is actually three types of muscle categories. First, we have smooth, we have cardiac, and we have skeletal. So cardiac muscle is the one found in the heart, right? The muscle that makes up the heart. Smooth muscle is every other organ is made from smooth muscle, right? So skeletal muscle is the muscle you can see and that connects to bones, ligaments, and tendons. So basically, skeletal muscle is voluntary and you can use it for voluntary actions like running and exercise. Then we have cardiac muscle. Cardiac muscle is basically going to be the muscle you find in your heart. And smooth muscle would be every other organ in the body. Why is smooth muscle and cardiac muscle separated when they both are found in organs? So the main reason why these two are divided into different categories is because, as the name says, smooth muscle is smooth and cardiac muscle has stripes just like skeletal muscle. Those stripes are myosin and actin, which we will get into their function later on. There's different movements for your muscles. First off, we have contractibility, which is the ability for your muscles to contract. As you're seeing on the screen, this is what contractibility looks like. Then we have extensibility, which you're seeing on the screen is followed sometimes by contractibility, right? It's your muscle's ability to extend. So as you can see, the muscle is extending. This is why we call it extensibility. Wow, crazy. Then we have elastability. Elastability is the muscle's ability to go back to its original position after contracting or extending. And excitability is your muscle's ability to receive stimuli, which comes from the neuromuscular junction, which comes from a signal sent from your brain. We'll get more into that later. So the way that you get energy is by something that's called the Krebs Cycle. So energy is made through the Krebs Cycle. Basically, energy that's called ATP, which is a form of energy, is produced. And as much as I don't want to talk about Krebs Cycle, it's really important, so it has to be talked about. Give me 1 second, I'll be right back. Bro, do you think they'll notice if I just pretend it glitches out and I just cut out the whole part of the Krebs Cycle?
No, they won't notice.
Alright, yeah, I'm gonna just do that. Okay guys, I'm back and let's talk about Krebs Cycle. Oh, wait. Alright, I hope you guys got all of that. Yeah, Krebs Cycle is kind of annoying, but you guys should have learned it with what I talked about, right? Perfect. Now, it's really important to know about the all or nothing principle. Your muscle contraction either occurs or it doesn't. It doesn't just occur halfway. So it either contracts or it doesn't. And it's really important also to know that muscles don't push, they pull. They always pull, they'll never push. But wait, when I do a push-up, isn't my muscle pushing up? No, you're doing the action of a push, but what's going on inside is pulling between the myosin and actin fibers, which we'll talk about sliding filament theory in a few minutes. Now let's talk about some terms. Recruitment is when your muscles recruit more fibers so that they can perform the task, right? So they need more fibers to help them out. Think about an ant. An ant can't carry food by itself, a piece of rice, so it recruits more ants in its colony so that they can help him pick it up, right? So same goes with picking up a box or curling a dumbbell, your muscles recruit more muscle fibers so that you can curl the dumbbell or pick up the box. Now, there's different type of muscle fibers. There's fast, slow, and intermediate. Fast fibers are basically those that move really quickly, but they get fatigued really fast. Then you have slow fibers. Slow fibers move slow, but they get tired not as quickly. They take a while to get worn out since they're not working as fast, using that much energy. So the example of a fast car versus an economic car can be used. A Toyota Prius doesn't waste a lot of gas and it has good gas mileage because honestly it doesn't go that fast. But if you're using a sports car like a Supra, since it accelerates faster, it's gonna be wasting more gas because of the bigger pistons on the engine, causing it to waste gas quickly, so it won't have more gas for later. So it ties in with the muscle fibers. Slower use of energy results in less fatigue. Faster use of energy results in more fatigue. Then we have intermediate muscle fibers, which have characteristics of both fast and slow muscle fibers. Muscles have origin and insertion. Origin is the head of a muscle and insertion is where the muscle ends. So, for example, the tricep has 3 heads, hence the name tri standing for 3. So it has 3 origins and then it has 1 insertion. So how do you name a muscle? In order to name a muscle, you use a few questions that are asked in order to find a proper name for that muscle. So let's try to name a bicep. How did they get the name bicep? First you ask, what is the direction of the muscle? Fusiform is the direction of the muscle, right? So that's what it's called because of the direction that the bicep is running. Then you ask where it's located. In the biceps case, it's located in the brachial region of your body. What size is it? So, what size is it wouldn't apply for the biceps specifically, but we have other things like the gluteus maximus and gluteus minimus and the gluteus medius. This is used when there is a lot of the same muscles, but there's different sizes. So, maximus, medius, and minimus is used to describe the size and the number of origins. So like I talked about before, since it has 2 origins, it has 2 heads, it's called bi, right? So bicep. So in conclusion, the bicep brachii gets its name from bi having 2 heads of origin and brachii, the location and region it's located in. That's tough. That's really tough. Alright, I kind of fixed it, but now it's answered. Whatever. So let's talk about the muscle contractions, as I was saying before I got interrupted. So there's different type of muscle contractions. Let's start with isotonic muscle contractions. Let's start with that one. Isotonic is going to be your normal muscle contractions where the muscle is contracting and extending. So that's what you usually do when you go to the gym. Most exercises use this, right? Then we have an isometric muscle contraction. So isometric is where the muscle is contracted but it stays in one place, meaning you're not moving around but your muscle is still contracted. An example of some exercises that might be like this are wall sits and planks.
Yo, bro, who got you smiling like that? Like, kill the lights.
Right? You could also do bicep dumbbell curls by using isometric contractions. It intensifies the workout and it breaks a lot of fibers. Then we have isokinetic, where the muscles move at whatever angle you want and a regulated speed using a machine called the dynamometer. Dynamometer. I don't know. Yeah, but this is used for therapy, is when you usually use this device, so you can get specific angles and specific speeds to make sure you're really working out the specific part you want. These machines are expensive and need to be programmed and used by professionals. Yes, I tried to get one. Didn't work out. We back in this ditch. Muscle news. This is the 11 p.m. edition. The most latest and improper news station you know, that can't even get up their wall panels set up correctly. We know what you guys are waiting for, so let's get straight into it. Brandon Valdez with his segment.
Oh, we're rolling? Right now? Excuse me. Good evening, everybody. I am Brandon Valdez. I am reporting to you live to what it appears to be my very own room. Very intriguing. Not really. I have recently received a message from the Muscular System Society where I was told to express some very important news with you all. To jump right into it, innervation and vascularization are directly related to muscle contraction. For the muscle to contract, it must be stimulated by a nerve impulse from a nerve cell. These contractions require a lot of energy. Along with energy, nutrients and oxygen are also needed. Waste must also be eliminated from this. Now, what is vascularization, you may ask? Vascularization is an essential factor for successful implants on bioengineered tissues, and a tissue of more than a few millimeters in volume cannot survive by diffusion and requires formation of new blood capillaries to supply essential oxygen and nutrients. Innervation, on the other hand, is a nerve supply, usually to a specific part of the body. They also sent me something else where it says muscles are composed of many fibers that are arranged in bundles. Those bundles are also known as fossas. Many individual muscles are separated by what we call a fossa. What is a fossa, you may ask? A fossa is a very thin casing of connective tissue that surrounds and holds every organ, blood vessel, bone, nerve fiber, and muscle in place. Secondly, the epimysium is a sheet of fibrous elastic tissue surrounding a muscle. Its main job is to prevent muscles from friction against other muscles and bones. It is the outermost layer that surrounds all of the muscle, also the muscle fibers, and its main role is to allow us to transmit lateral and contractile movements. Lastly, the endomysium is the center portion of the intermuscular connective tissue. It is directly in contact with every single muscle fiber, as its job is just to completely surround it. This is what allows for it to form the immediate external environment. Muscles that have endomysium are also known as skeletal muscles. That is all I have for today. Thank you very much for joining me here today. I am Brandon Valdez, and I'll catch you all in the next one.
Thank you, Brandon. That was wonderful. Now, have you ever wanted a pill that can cure all muscle pains, no matter the muscle, even heart muscle pain? You heard of that? Me either. Actually, yeah, that disease right there, that's heart muscle pain. Anyways, here's a short commercial so that you can find the cure and finally have a relief to this pain. Hi, thank you for joining us for this short commercial. We're honored to be on Muscle News, and we're honored to share this really innovative studied pill. It's been studied for about 2 years, and we're finally so stoked to share it with you guys. So here we got a non-paid person that has tested it, and please tell us what your experience is with the pill and the difference it's made in your life.
Hi, my name is Vanilla Bean, and ever since I took Muscle Pain Go Away, I have not had muscle pain.
Inspiration.
It really has worked, although I think it is a little overpriced. You could get Advil and it'll be the same effect.
It's only $500 a pill.
Yeah, you could get a little Advil thing for
Don't say that. That's another. We're trying to promote the.
I mean, you could also get ibuprofen
Don't
or
say any
Tylenol or.
You can't talk about other painkillers. This one's specifically for muscles. It's different.
I mean, it works.
Alright, so look at the camera and smile. Okay? We'll do the outro. Thank you for joining us, and as we said, we're stoked to be sharing this really clinically studied pill, and we hope to be seeing you using it in the future. And trust us, folks, it will change your life. Thank you. Cut. Yeah. Alright.
Are we done?
Oh yeah, I cut it. Yeah.
Oh, where's my money?
Oh, here. My bad. So we agreed on.
Yeah, looks good.
Perfect.
Thanks. And just wait a second. This isn't real.
No, yeah, it is.
No.
We haven't.
It literally says play money on
Right,
it.
but we haven't made sales on
Please
the.
do not take muscle pain go away if you have type 1 diabetes or type 2 diabetes. Muscle pain go away can also cause type 4 diabetes and even type 5 diabetes. Please do not take muscle pain go away if you plan on having a kid, or if you've had one, or if you're a guy. If you are vaccinated with the COVID vaccine, please do not take it either. If you're not vaccinated, please do not take this pill. Muscle pain go away does not actually cure any type of pain, but it could cause serious illnesses to the muscles and could even result in paralysis or death. Please contact your doctor today to see if muscle pain go away is right for you.
We hope you enjoyed that short commercial by Muscle Pain Go Away. We are really stoked to see you guys trying this new pill out, and it's like nothing ever made before. Thank you guys for joining us for Muscle News 11 p.m. edition today, and we'll see you tomorrow at 8 a.m. sharp. Thank you. Have a good night, folks.
Sliding filament theory is the mechanism by which muscles are thought to contract at a cellular level. An understanding of the structure of skeletal muscle is useful when learning how sliding filament theory works. Each muscle is made up of a number of bundles of muscle fibers. Each bundle of muscle fibers contains anywhere from 10 and 100 individual fibers. Each muscle fiber itself contains cylindrical organelles known as myofibrils, which themselves are bundles of proteins called actin and myosin. Surrounding the myofibril, there is a network of tubules and channels called the sarcoplasmic reticulum, where calcium is stored. Each myofibril can be broken down into functional repeating segments called sarcomeres. If we look at a two-dimensional model of a sarcomere, it consists of actin and myosin. When a nerve impulse arrives at the muscle, it causes a release of a chemical called acetylcholine. The presence of acetylcholine causes depolarization, enabling calcium to be released from the sarcoplasmic reticulum. The calcium binds to troponin, changing its shape and so moving tropomyosin from the active site of the actin. The myosin filaments can now attach to the actin, forming a cross bridge. The breakdown of ATP releases energy, which enables the myosin to pull the actin filaments inwards, contracting the muscle. This occurs along the entire length of every myofibril in the muscle cell. When an ATP molecule binds to the myosin head, the myosin detaches from the actin and the cross bridge is broken. When the ATP is then broken down, the myosin head can again attach to an actin binding site further along the actin filament and repeat the process. This repeated pulling of the actin over the myosin is often known as the ratchet mechanism. This process of muscular contraction can last for as long as there are adequate ATP and Ca+ stores. Once the nerve impulse stops, the Ca+ is pumped back to the sarcoplasmic reticulum and the actin returns to its resting position, causing the muscle to lengthen and relax.